Alright, in this video let's talk about different ways that we have to allocate buffers, and let's see which one of these is the fastest way of doing it. Alright, so I'm just gonna go ahead right here in my buffers folder. I'm gonna create a new file and let's call it maybe different dash maybe alex.js. Okay, and right here I'm just going to first include the buffer object. So const buffer equals require buffer. Now we already talked about this method that we have, which is called buffer.alloc. So const buffer equals buffer.alloc. And right here we'll just specify the size of the buffer, maybe 5,000 or 10,000. And what this does is that it's going to allocate a piece of our memory to us, and it's going to fill all the elements, so it's zero filled. And if you see here as the second arguments, you can specify what you want to use to fill all the elements. By default, it's 0. So if you don't specify anything here in the alloc function, it's going to be 0 filled. So it's going to take this 0 and it's going to fill all the elements, all the 10,000 elements with that 0. Now, this filling thing that this alloc does is something that takes time, all right? So it will go ahead, it will allocate a piece of memory. In that piece of memory, there could be some existing data, but it's just going to write 0 to all the elements. So it's going to just zero out the whole portion of the memory that it has allocated, all right? So this filling operation for sure takes some time. Now, there's another way of doing this, and this is now faster because it doesn't zero out the whole portion. And this method is called buffer.alloc unsafe. All right, so what this does is that you just specify your number again, whatever you want the size of the buffer to be, and it's going to allocate a piece of your memory to you, but it's not going to bother with zeroing out that portion. It's just going to allocate that piece, and that's it. You now have that piece, and well, it's not zero out. So there could be some existing data in that piece of memory that has just been allocated to you. And this is faster compared to this one, all right? Because in this case, we don't care to just write 0 on all the elements and then write our actual data. We'll just get that piece and then we write to it as we wish. But there could also be some existing data there. So this is faster compared to this one, all right? But there's a caveat. Here in this method, well, as you can see here, the name explicitly says unsafe. All right, so Node.js wants you to be sure that this way of allocating your buffer is not safe. Now, why is that the case? Again, the reason is because this buffer that you're going to get, it could have some existing data, and that data could be potentially some sensitive data. All right, so you have that piece of data in your memory. Maybe it's something that you used previously, maybe an API key or a password or whatever else that could be important. And that data could end up being here in this buffer, all right? And then a hacker, if you are specifying something here, a hacker could specify something back here and then somehow access that buffer and then be able to see the contents of that memory. And that could be problematic if your application is really security sensitive and you have to take security really seriously. Now, let me just show you this pretty quick. I'm just going to save this in a variable called unsafe buffer. All right. And what I'm going to do is that I'm just going to loop through this buffer pretty quick. So I'm going to say for let I equals 0 and then I less than unsafe buffer dot length and then I++. And for each element, I'm just going to check if there's data in that element or not. So I'm going to say if unsafe buffer, and I'm going to access the position at I. Now remember, when we access an element of a buffer like this number is going to be given to us in decimal. So I can just go ahead and say if this is not 0, now this means that now we have some amount of data at that particular element, at the element with position I. And here, if that's the case, let's just log something. So I'm going to say console.log, and let's just say that elements at position I has value, and here I'm just going to say unsafe buffer dot not dot, but the position that's I and dot, let's just convert it into toString, and let's just log the binary number, okay? So we can just do that here in the toString. We can specify something, we can specify a base for the number. So if you run this toString on a number, remember that this item, this is what it's going to be returned, it's going to be a decimal number. So in JavaScript you can just use the toString on a decimal, on an integer, and here we can specify a base. And your base could be anything between 2 to 35, I guess. So base 2 is binary, so I'm just going to say that take this value, which is decimal, and just display that in binary, okay? Just so that we have something that kind of makes sense, okay? We can also just log the decimal or hexadecimal, it's totally fine, but let's just go with this. And it's complaining about something here. Yeah, I'm missing an N here. All right, there we go. So let's just run this code a few times, or maybe in the first time, and see what we'll get. So let's see if we can get to this log. Let's see if we are allocating this unsafe buffer. Let's see if we have some existing data there. So I'm just going to run this. I'm going to say node different-alex.js. And if I run this, now as you can see here, we've got a lot of data in that buffer that we just allocated. And it starts, it's probably more than this, so it just started to display the logs starting from the position 7,000. But there should be more. Maybe my terminal is not allowing the rest to be displayed. Anyway, the point is that we've got a few elements here and a lot of elements that have some existing data in them. And this could really introduce a security risk in your application. So we don't know what this data is. It could be something sensitive or it couldn't be something sensitive. We don't know. But if you are creating a very security sensitive application, this could be some potentially sensitive data and you have to take care of it. Because again, a hacker could somehow get access to this buffer, and then they have access to the contents of your memory, and there they could find some potentially sensitive information. Now if I just change this from unsafe buffer to this buffer, and notice here that we're specifying this fill option, but if you don't do it, it's going to be just a default 1 to 0, 1. And also we don't have that option here. So here in alloc unsafe, the only option that we have is the size, okay? So you can't just fill it as you would here. If you want to fill it, you can just say unsafe buffer dot fill 0, okay? So you can do that, but you can't do it in a single line. But here you could. But now if I just change my for loop to use this buffer instead, so I'm just gonna hit Command D a few times and just change all of them to buffer like this. If I go ahead and run this code, notice that I'm not gonna get any logs whatsoever. And that's because all of my elements in here in this buffer are all 0. But here in unsafe buffer, well, that is not the case. So in unsafe buffer, here I could get some potentially sensitive data. And notice that if you run this code, you might not get some logs. I mean, in my case, I just ran it a few times. At some point, it was all 0s, so it could also be all 0s. It's not something that's definite. It's not always going to have some amount of data, but it could sometimes, and that sometimes it could be a sensitive information. So you have to be careful about that. Nonetheless, this is faster than this one, and you could use this if you are sure that you are just going to fill all the elements right off the bat. Okay, so if you want to do this, don't leave this unsafe buffer hanging. Just fill it up as soon as you can, and also make sure that you're not really using any user input things here. So you just got to make sure that you sanitize the inputs. Just if you're, for example, getting a JSON object, and there you're reading a value and you're putting that value right here, that could really introduce a lot of problems. So you have to make sure, you have to take some security precautions. You have to take some security items into account. Now we're going to have a dedicated section in this course just talking about security, but right now I also wanted to point this out that you can just go with this, which is a bit faster, but you are introducing some potential security risks that you have to take into account. Now, if you were using other methods to allocate a buffer, such as buffer.from or buffer.concat, now we can use this buffer.concat to just specify a list of buffers, and then it's going to return a buffer with all those buffers added together. Now these two methods, they use a buffer.alloc unsafe behind the scenes. But here they are filling it as soon as possible. So these two methods will allocate a buffer that is just the right size. So they don't allocate a buffer that's bigger than what you require. And also they fill it up with the data that you need. Okay, so these two methods, even though they're using alloc unsafe, are safe. Okay, so you can also do the same thing. You can allocate a buffer using this method, but you have to make sure that you're just using the right size and you're filling every single element with the data that you want. So don't allocate an unsafe buffer like this and then just leave it be there in your application, all with data potentially from something else in your application. So just don't do that. Make sure that, and if you just want to do that, it's much better to just stick with alloc. And if you really want to maximize the speed of your application, maybe it's a code you have to run millions of times, and in each case you are allocating a buffer. In those cases, it's better to just stick with this. But then again, take security into account that here you can have potentially some sensitive data, and a hacker can just take that. All right, so this is one reason why alloc unsafe is faster than alloc. Now, there's also another reason why this is faster than this one, but only for specific sizes. Now, to understand this one, we first have to understand something about Node. All right, so here in our slides, here again, we've got this diagram, we've got our Node process right here, we've got our operating system, and then we've got our hardware right here. Now, we're focusing on our RAM right here, on our memory. So let's say that we have our Node process, and then we've got our memory. In this case, it's 2 gig. So just like that operating system that I ran, that Linux thing, so this could be the diagram for that. Now, as soon as you run your Node application, what Node does is that it will allocate a piece of your memory for itself, and the size of which is this much. So as soon as you run your Node, it will allocate a piece of your memory so that it could use that already allocated piece for future buffers. Okay, if the size matches this one. So we'll use this piece to allocate these buffers, so now it is faster. Okay. Now the size of this piece is 8 kilobyte. It's not 8 kilobyte, it's 8 kilobyte. And the difference is that 8 kilobyte is 8 times 1000, so 8000 bytes. But kilobyte is a bit different. It's 8 times 1024. Okay, so it's just a little bit different, but still similar. But it's something that you should keep in mind, because if you're just dealing with bytes, if you just miss 1 byte, you might get different results. So it's just something to keep in mind. And you can get this value by running buffer.pullSize. So in your application, if you just log buffer.pullSize, you're going to get the value of this. So this is the value, this is the buffer that Node has already allocated. So Node has access to this piece, and if you were going to create a buffer, it's just going to slice a piece of this and put your data in there. Okay, so it's now not going to bother with allocating a piece of your memory and then do some stuff there. So it's now faster having this memory already allocated. Now, a very important point here is that you can only make use of this if you use the buffer.alloc unsafe function. Okay, so if you use buffer.alloc, you're not going to make use of this allocated buffer. Okay, this 8 kilobyte thing right here. You're not going to make use of this pull. But if you use alloc unsafe, you will make use of it. But there's also another condition. Here in these 3 dots, the size that you specify should match the size of this, and this size should be less than the floor of this value divided by 2. Now, this is what Node.js uses in the documentation. So we're going to see this operator, and I'm going to talk about what this means in just a minute. For now, though, this is just equal to buffer.pullSize. So if you take this value, which is 8000 something, you divide that by 2, and you take the floor of that, this is exactly the same number. Okay, so if you use the alloc unsafe and you specify a value that is less than this value, in that case, you're going to make use of this piece, right? And it's the fastest possible way of allocating buffers. So using alloc unsafe and specifying something that is less than this value. In that case, you're going to use this piece. Now, if you use buffer.alloc, not alloc unsafe, just alloc, you're not going to use this piece. Node will just allocate a piece to you that is outside of this, and it's not pre-allocated. Now, if you use .from or .concat, it's the same thing because they're using alloc unsafe. Node will make use of this already allocated piece, given the fact that, of course, the size of your data is less than buffer.pullSize divided by 2 and the floor of that. Now, this operator here is a JavaScript operator, and all that it means is that it's just going to take a binary number and it's going to shift it to right by 1 bit, okay, by this number. So if you specify 2, it's going to shift that number to the right by 2. So if I have this binary number right here, okay, so it's an 8-bit number, And if I just take this number and I use that 3-arrow operator thing on it, what's going to happen is that JavaScript is going to take this number and it's going to shift it to the right by 1 bit. So it's just going to drop the least significant bit. So it's just going to drop that number, and then it's going to shift the number to right by just 1 bit, and it's just going to put some leading zeros like so. All right, so it's very simple. Okay, don't be confused when you see that operator. You'll see that mentioned in the node docs. It just means to take the number and shift it to the right by 1 bit. And this is how computers do divisions. If you do this, you are dividing your number by 2, and you're also taking the floor of the result. So let me just show you one example. So here in my calculator, if I just put in a number, let's say maybe 60, right? So here's my binary number right here. If I just shift all the bits to right by 1, so I'll take this one, I'll move it here, I'll take this one, I'll move it here, and I'll take this one, I'll move it here, and I'll take this one, and I'll move it here. You can see that I ended up with 30, okay? So 60 divided by 2 is 30. If I do the same thing again, so I'll take this bit, move it here, this one here, this one here, and this one here, I'm gonna end up with 15. Okay, so this is how computers do divisions. They just take a number and move it to the right by 1 bit. Now you can also do it by 2 bits or by however value you want. And now this is the number that you're gonna end up with. Now if it's an odd number like this 15, it's gonna also become the floor of the result of the division. So if I just take this 15 and I move it right by 1 bit, so now this bit will be dropped. So I'm going to move this here, and now I'm going to move this here, and I'm also going to move this here. So it's going to be 15 divided by 2, which is 7.5, but the floor of this, which is 7. Okay, so this is all that that operator does. And if you go into your terminal and you go into Node, you can also do this in your console, in your web browser. It has nothing to do with Node. It's just a JavaScript concept. Here, if I maybe put a number and then shift it to the right by 1, I'm going to get the value divided by 2 and the floor of the result. So again, 30, I'm going to get 15, and then if I take 15, do the same thing, I'm going to get 7. I can also do it all in one step, so I can say 30 by 2, and I'm going to get 7. You can also do it the other way around. You can move the bits to the left side, so you could do it like this. Now, it will do the exact same opposite, okay? Now, computers are really efficient with this. They can easily flip bits over. They can move bits around, shift it to the right, shift it to the left, and it's a very common operation. It's a very common thing that your CPU does. And again, this is how computers add numbers together, divide, multiply, and all that stuff. All right, so that's just something that I wanted to point out. Now, again, the point is that if you specify a value here that's less than that size, so here I'm going to say console.log buffer.pull size, shift it to the right by 1 bit, and I'm just going to run this, and I'm also going to comment my for loop. Now, this value that I'm going to get is going to be 4 kilobytes. So node different alex.js, and here you can see that value. So if you specify something here in this buffer.alloc unsafe that's less than this, you're going to take advantage of that buffer that has already been allocated for Node. Okay, so 2 different ways of allocating buffers, alloc and alloc unsafe. All right, and hopefully now you know that this is faster because of 2 reasons. It could make use of that buffer that has already been allocated, and also it won't try to initialize all the elements to 0 first. Now we've also got one other way of doing this, and it's called a buffer. So I'm just going to call this one buff. This is buffer.alloc unsafe slow. Now what this does is that it's similar to unsafe, meaning that it's not going to initialize your buffer with something, so you can only specify the size. You can't specify anything else like buffer.alloc. You can't specify how you want to fill it, just one thing, and that thing is your size. All right, just the size. But the difference between this one and this one is that it will not try to make use of that buffer that has already been allocated. So buffer.pull. So this buffer right here, now this is only the size, but you get the idea. The buffer that Node has already allocated. This method will not try to make use of that buffer whatsoever. Okay, so that's why it has the name slow. But still, it won't try to initialize a buffer, so that's a good side, but it won't try to make use of that internal buffer. Now, this could sometimes be useful if you just want to create a buffer, just fill the data, and then just leave it be there for minutes, for a very long time, and you don't want to really touch that buffer so that your application could be still optimized for other buffer allocations. So you can do this, you can just allocate something, just leave it be there, you just want to do it once. So this again could be a good option to use if again you just want to allocate a piece and then save some data there, and you just want to do it once, just want to do it for a very small number of times, and just maybe want to keep that there so you are not touching that internal buffer. So when you're trying to allocate the rest of the buffers, they could make use of that already allocated buffer. Okay, so that's it about this video. We talked about alloc, alloc unsafe, and alloc unsafe slow. So these are 3 different ways that you have a node to allocate buffers, and also the other methods you have, such as concat and from. Well, they will also create a new buffer. They just use these ones behind the scenes. Well, to be more specific, they use alloc unsafe. Alright, so that's it about this video, and I will see you in the next one.